Hey folks.
Hello, guys.
Hey, hey.
Start sharing. We've got a lot of stuff on the agenda today, so I suspect we probably won't finish it all, but um, we can see what we can get through. Guess we'll give it a minute or so for other people to join. Okay, I guess we can get started and catch them up if they're joining late. A couple of high priority things to start with, and then Sonko is ready for it, we can pick up part two of the CDI discussion, and then if we've got time to talk about some of the other issues, we can do. So yeah, I just wanted to draw. So actually, Troy discovered this. So from yesterday, the Docker tests started failing in the nightlies. Um, I originally wondered if it could be related to one of the PRs that got merged yesterday, but I reran the day before's nightly, which had passed, and it failed now. So with exactly the same code. So it looks like it's probably an infra issue. The particular error we're getting is not able to resolve the github.com host name. I don't know if anyone's got any ideas or if, yeah, but I wondered if we just make it non-required at the moment because it's blocking PRs. But obviously we want to, it would be nice to get the Docker tests back working. So any thoughts or comments on this?
Just mark them as as not required.
Any others?
Can you also open an issue for that? Either
Yeah.
you or Joy.
Yeah. Okay. Cool. We'll move on. Um, we're heading to the middle of the month, so the 3.17 release is at our kind of normal schedule, would be due at the end of next week. So yeah, I don't know if anyone knows of any outstanding issues or features that they want um, fixed in it yet. It will likely form the basis of Cocoa 0.14, I think we're on. So there might be something that the wider Cocoa community are after, but I thought I'd check if there's anything from our side that we know needs resolving. Okay, sounds like not. I don't know if we want to aim for like next Thursday, so we can, or post next Thursday, so Monday or Friday, so we can just have a sync again on the AC call next week. Any objections to that?
Nope.
No, that is one call. I'm not trying to add stuff to your back. I just would like to know what is the status of the Helm
Helm doc?
documentation, and if you want to actually have that as part of this release.
All right. So peop, uh, people have pinging me if we could also publish the Helm chart.
In our GitHub, okay, I can open up PR for that. That's like 2 minutes from my side.
In a repo, so that we are pushing it. So not only in a OCI registry or some Helm repo, where rather than going over the release page and then directly using the tar file, rather than Helm repo add blah blah Helm
Yeah,
update.
what the person wants to do is just pass the OCI artifact and just do a Helm install passing the OCI artifact, right?
Yeah. Yeah, well, the
Uh,
Helm can save the Helm supports OCI as a storage backend, so you can create a repository in an OCI registry.
yeah, I think we can do that on our DHCR. That's
Mhm.
like one command as part of the release.
Yeah.
I don't think we should do this for every pull request.
No, no, I'm not saying that.
Okay,
I'm not saying that. This is just for the release, and for the PRs, you still have the blob that you can directly Helm install. Yeah. So if we push it to a registry, so should this be the default then, that we're using it from the OCI registry rather than directly using the tar file from the release page?
I think so.
Okay, then we'll need to update the documentation there. And I don't know if you've seen the thread on Kata Dev with this guy, Craytonian. I've walked him through, you know, a complete installation, how to create your kube config and stuff like that, and what are the drawbacks with K3S. And I don't know if I should include that, but I think I'm going to update today the PR with some points from the session that I had with him and how he installed Kata. So if we have the push to the OCI registry, I'm happy to update the PR, and then let's target this PR to have it for the next release. That's a good point. Yeah.
Okay, so I will open the PR today, push into the registry,
Okay.
and then like I will review the Helm docs as soon as
Okay.
you feel comfortable asking
Yeah,
for
yeah,
a
yeah.
review on that.
I mean, it's already done. I've Steve pointed out some typos, so I updated this. So essentially, it's ready. The only thing is the push to OCI registry.
Cool. Steve, so we have at least two PRs. So Helm related stuff we will try to get
Mhm.
into this release. And I
Mhm.
guess that has this part covered at least from my side.
Cool. Sounds good. Yeah, I know there is quite a few bits from the Cocoa side hanging around, like the move of um, to move image RS outside of the agent and stuff like that. And there's some discussions about Snapshotter. I don't know if any of them will land in the next hour. I think we'll probably be discussing this, so we can give some feedback and see what happens there as well. Cool. Okay. Yeah, like I say, there is a few other topics. Is there anything like super high priority people want to talk about now before we jump into the the CDI part 2. And are you able to share, Zonko, or do you want me to share again?
No, I prepared this time, so
Okay, cool.
I switched from Wayland to good old X11, which lets me share anything, desktops, tabs, presentations. So let me just share it. Bam, bam, bam. Can we? Is it visible?
I can see it. Yeah.
Okay,
It's
perfect.
not in presentation mode, but it's viewable. So
Yeah, just wanted. Yeah, it's easier for me here to jump than slides, but I hope it's big enough for you guys to see. Okay, small refresher last time where we explain how the CRI works. So one thing to keep in mind is really that's a sequential operation of creating a pod, aka sandbox, with the containers, right? So first step is pod sandbox creation, which just holds the pause container. So the CRI will only have the information about this pause container, nothing about the workload containers that are coming in. Pod sandbox, create this, create a pause container. Then we get all the containers inside of the pod sandbox created with all the information of the container that it needs, with all the requests and limits and resource allocations, memory, CPU, VFIO devices, extended resources, CDI devices, and all this stuff, right? Container 1, container 2 comes in, container 3 comes in. And so this is essentially the flow, and this is by design. Essentially, the kubelet tells you when and how to create things, right? So status quo today, how we are fixing this, and this is by example of the GPU, is that at pod sandbox, where we're creating the VM, we need to provide additional information to the VMM to build or to create the correct devices for the VM that we need later on in later stages for the container. So at pod sandbox creation time, when we are spinning up or doing the start VM thing, we can provide annotations in the pod YAML, which are passthrough by containerd. So already in the containerd config, we have pod annotations enabled, which are io.kata container. And those annotations are used inside of the Kata runtime to distinguish, okay, are we getting a pod sandbox? Are we getting a pod container? Or is it a single container? A single container type is when we are launching Kata with nerdctl or Docker or Podman, right? So this is a single container case. For Kubernetes, we need to distinguish between the pod sandbox and the pod container. So when the request comes in to create a pod sandbox, with the cap, we have the possibility, or the CRI already has CDI devices in the CRI encoded. So with the cap, we can pass through this at the sandbox. But today, what we're doing is we are creating a CDI annotation with the VFIO device that we need at pod sandbox creation. So the CDI annotation would look like cdi.kubernetes io, and then we have nvidia.com/VFIO, and then 0 the index. Which means at the pod sandbox, the device is a VFIO device, and in the sandbox VMM, we can use this information through the annotation to create the PCI topology, because we now know how many GPUs are coming in or other network devices. And then we can create the amount of PCI root ports or PCI switch ports. The same is for any other device. But you need to remember here, that's a pod-wide device. At this stage, we don't know where or how this GPU to which container is going to be hot plugged. So The only thing that we can create or can take off care of in the sandbox create time is preparing the VM with the, let's say, the PCI topology. So any other device that it's pass-throughs via annotation is a pod-wise device. So you need to make sure that you have additional information at create container time to know which VFIO device needs to be hot plugged into which container. At Sandbox, we are just preparing the VM and sizing the VM. We cannot deduce anything about how and when. Well, we could. One solution is also to encode the complete pod YAML as a base 64 string and send it over as annotation in the pod sandbox creation time. So we would have essentially all the information that we need at pod sandbox. But this is, I don't know if this is feasible or we should do that, but essentially we could pass through all the pod information via annotation inside of the Kata runtime, and then we would have all the information needed for all the containers, all the pod sandbox. The only thing is that at this time, when a sandbox is created and all the complete pod spec is sent over, Kubelet has not resolved all the CSI and CNI stuff. So this could create some problems here.
Zvonko, just to
yeah.
mention one thing, the responsibility then to pass this down to Kata containers to the pod sandbox, it becomes the responsibility of the container runtime, or sorry, the container engine, if you prefer. So it would be like either containerd or Cryo who would be responsible for doing that.
Yeah.
And I think that Cryo already does something like that. Just mention.
Yeah. Okay. Right. So you need to make sure that any runtime can pass through the annotation that are done in the pod spec. Now, the problem that we are seeing and what we are trying to fix with the cap is that someone or some entity needs to add this annotation to the pod spec, and it needs to be a resource management thing. So currently, what I have as a POC is using the device plugin, which is the device manager API in the kubelet, which handles the extended resources that are exposed to the cluster with a mutating webhook. So if I allocate a GPU in a traditional way via extended resource, a mutating webhook knows which GPU is allocated by the kubelet, but this is not visible by the Kata runtime, right? So we need to make sure that the sandbox knows how many GPUs. At the sandbox stage, we don't care at the Kata runtime which GPU goes to which container. It's just the amount of how many GPUs are allocated. But on the device manager side, we need to know which GPUs are allocated so that we can pass it properly at the create container time so that we can create the mapping. So what happens, we have all the VFIO devices, and inside of the runtime, depending on the configuration toml, if we are saying cold plugging or hot plugging, we are creating the PCI topology, creating all the PCI root ports or switch ports. If it's cold plug, we are directly attaching the GPUs to the VM. And if we have hot plug, the hot plug happens in the create container time. So, right. So we have the information, how many GPUs, we can size the VM, we can create the PCI root ports, switch ports, whatever else. We can create a sandbox, and the CRI will create the post container. And when create container happens, we don't need the annotation anymore, but we need still the device information of which VFIO device is attached or is going to be attached to which container. And this is where the device manager or the device plugin comes into play, because the device plugin will have the information about which VFIO device is going to be attached to the container that requested it. But this same device, a CDI device, was already sent as a CDI annotation at sandbox creation time. So we have attached, if we are doing cold plug, we already attached the correct GPU to the VM. And at create container, we have the VFIO device. We know which VFIO device goes to which container, which is provided by the device manager API. So with the annotations, we provided the information at sandbox so that you can create a topology or any other functionality that needs to be done for the device. And at create container, the device manager API provides us the VFIO device that needs to be attached to the container. So now for GPUs, it's a little bit more complicated than just attaching the VFIO device. So in Kata, we also have two VFIO modes. So we can pass through the VFIO as a VFIO device to the container to enable use cases like DBDK that are only working on VFIO devices and not really on a GPU device. And then we have the guest kernel VFIO mode, which creates a GPU from the VFIO device. So in the VM, it's not a VFIO device anymore. It's a GPU device, a true PCI device with def and sysfs entries. So for the GPU use case, we need to do a second step so that the Kata agent in the VM knows how to handle this device that is now a GPU device or any other device inside a VM. Going back here, so we have a CDI spec on the host, which describes how this VFIO device looks like, what needs to be done to the runtime, which device needs to be hot plugged, what's the device path on the host, attributes of the host, annotations if you need to provide more meta information about the device. So you have a CDI spec on the host, which handles the VFIO device or any other device that's on the host. And when create container happens, the VFIO device is transformed into a real GPU device inside of the VM. So you need an additional CDI spec for the Kata agent to handle this new device for the container. So we have a function that's annotate VFIO container. For the GPU case, a index is needed to reference it in the CDI spec. The CDI spec is created by the NVIDIA Container Toolkit. And the very same mechanisms that you would do on bare metal with the NVIDIA Toolkit and the device plugin, we just transformed into the VM. So the very same functionality works here as well. But we need to take care of some of the things because the index is based on the PCI topology. So we need to create a proper mapping from the VFIO device, VFIO 17 on the host, what becomes a GPU inside the VM on a specific PCI root port, and then this becomes an index, and this index is determined by the driver and how the PCI topology looks like. So CDI spec on the host and CDI spec inside of the VM. With this CDI spec inside of the VM, the Kata agent knows how to enable this GPU inside or for the container. The GPU enablement is done by bind mounts of devices, libraries, binaries, and some other configuration files into the container. So we need the proper mapping for the GPU with the index created by the CDI spec inside of the VM for the Kata agent to map the correct GPU to the correct container. So depending on what the use case is and which device is going to be passed through into the container, you need to make sure that on the host, you have the correct CDI spec. You need to create a connection between the CDI annotation that is passed through at sandbox creation time and the device plugin. Oh my God. Give me a second. They are starting to mow my lawn here. Need to close the window. Okay, I'm back. Yeah, so you need to make sure that this mapping of the CDI annotation is the correct one with the mapping that the device manager is providing you at the create container time. So this is currently a hack on how we are doing this, and that's why it's important that we have the cap working. Otherwise, you would always have to have this mutating webhook and a device manager or a device plugin that provides the correct information inside of the VM. Let me just see if I have anything else. Oh yeah, and the Kata agent. So we have a callback edit in the Kata agent, which is called handle CDI devices. So as soon as the Kata agent sees a OCI spec, so we are creating two annotations, the annotations on the host side and the annotation on the spec inside of the VM. And if the Kata agent detects a CDI annotation, it will wait for these CDI specs to be created with a timeout. Because if you're looking at the GPU lifecycle, as soon as the GPU is added, we need to load the driver, we need to initialize the GPU. This takes some time. So the sync point is on the CDI spec creation. The Kata agent will wait until the CDI spec is created. Once the CDI spec and all devices are resolved, Kata agent executes all the instructions in the CDI spec and bind mounts all the needed pieces into the container. After handle CDI is done, we do the init rootfs with the spec mounts, and the spec mounts will have all the populated bind mounts that we need, let's say for the GPU use case or any other use case. Okay, questions?
Yeah, thanks. So I was just wondering, like, you mentioned several services that may generate like the CDI specs. So
Yeah.
is that the container toolkit or what's running in the VM?
In the VM, we have the NVIDIA Container Toolkit running, which creates the CDI spec. So you need some entity which is in your flow on enabling the device that creates the CDI spec. If it's a static device, which does not change, let's say the index does not change because you always know that this device will be let's say if it's a static CDI spec that does not change independent of how you configure the VM, right? Could be some sysfs entry or a dev whatever else, right? Which does not change depending on the driver, how you load it on the PCI topology. You could package the CDI spec with the rootfs, but then you need to make sure that the runtime annotates the CDI spec for the container inside of the runtime to use this device. So it's dependent if the CDI spec is dynamic or static. So one entity needs to create that.
Okay, but assuming that I can plug either 0 or 1 or n GPUs into one pod, I will need something dynamic in the guest, right?
Exactly, because
Okay.
depending on there are several configurations. One is the VFIO mode. Second is if you're using PCI root ports or switch ports, and then it depends on the driver version. With the driver could also, let's say, start to enumerate the index by a different order, or the kernel enumerates the BDFs, the bus device function addresses differently. So currently we are assuming that the lowest BDF will get index 0 and the highest BDF will get the highest index, which is a convention here. But really it depends on how the device appears, because the index is then the file handle to the CDI spec. So you would have in the CDI spec, you would have a name for an entry with a name 0, which is some NVIDIA.com GPU or Intel.com DPU or whatever else. So you need to make sure that the annotation that's created inside of the runtime for the Kata agent is mapping to a correct CDI spec.
And if I remember correctly, the container toolkit also like it does not just add like a device to the OCI spec, but also mounts for drivers and such, right?
Yeah. So
And then you don't need any guest hooks anymore, correct?
exactly. So
Yeah.
I started with guest hooks like way back because this before we even had CDI, but guest hooks. There was always some CVEs on guest hooks, so guest hooks shouldn't be really used for such runtime modifications. It should be really done by CDI and not by. So the runtime should be solely because the guest hook runs with the same privileges as the runtime, and essentially a hook can do anything that the runtime can do. So you have the highest privileges as a hook. And with the CDI spec, you have a DSL telling the runtime what needs to be done and what not. Yeah, but you're right. They are for the GPU. We are adding stub libraries to make sure that the user space and kernel space, the user space part and the kernel space part are matching. Way before people were shipping drivers with the container, so the user space and kernel space password at the container, which created a lot of um, discrepancies in the driver on the host and the driver in the container. So for the GPU's case, you are bind mounting stub libraries and driver files and sysfs entries and configuration files, so that makes sure that user space and kernel space are always in sync.
Cool. Thanks.
Just to confirm, when you mention user space and kernel space, you are talking about the guests, everything inside the guest,
Yes.
not the host.
No, not the host.
Okay. I guess one question that I have, we have been adding support to CDI, we have been adding more and more code to this, and it seems to work. You know that I love CI. It sounds like a joke, but no, like I love having CI because I love having like quick examples that I can just go there, take a look and see how things are working. So I guess you imagine my question, right? So when CI for this is coming?
Say again. I didn't catch the last.
When will we have CDI being tested by RCI? So
Oh, okay.
we've got.
Let me share a PR. Where's my PR?
I guess I saw that. It's one PR that you have been working on that since yesterday more actively.
Yeah. I need to. So yeah, I will have this ready by end of week for review. That's the GPU CI/CD that I explained. What I want to build up is a simpler rack pipeline. So have um, we have a inferencing server running, which can do open AI API requests. You can ask it questions with curl. So what I'm doing is asking the inferencing server what is Kata containers, giving me an answer, feeding in the Kata documentation HTML files, do some re-ranking on them, and then ask specific questions about the documentation of Kata containers. So this is what I'm trying to build in the CI/CD, and also I want to add a SMP machine to it so that we can run this also in a confidential container. Again, inferencing service asking stupid questions, and which will be part of the CI/CD. So for every PR, we are running some simple rec pipeline. It's not time-wise. It's not a very long process. It's a small model that we're using here, but then again, I want to extend it to use also the Nebula stuff that we discussed before to create a small confidential mesh so that the rec pipeline is only running and exchanging information over this small confidential mesh rather than over the Kubernetes control plane and Kubernetes APIs. So that's the goal. This PR is the first step of adding the inferencing server, then the re-ranking, then the SMP machine. I have also an ARM machine. I want to add the Grace Hopper machine so that we are testing CDI on ARM as well. So we will coverage on AMD 64, ARM 64, and SMP machine. So yeah, that's the goal for the CI/CD,
Nice.
which will run CDI for every PR.
Okay, any more questions for Sonko before we move on? Okay. Cool. So yes, let's get going. So as part of the changes from last PTG, we updated our governance to make a suggestion that we would review the list of committers that we have on GitHub and the admins and owners as well at the AC election cycle to remove people who are no longer committers. So I was looking at writing a program to make that change, but as part of that, I found some issues with the current electorate generator and just some improvements that I made. So I've created a PR on the community repo for that. I've then got some follow-up code that does it, and I think at the moment the stats are something like 50% of the people who are currently on our committer list haven't made a code contribution for more than a year. I think it might even be more than that. So I think it is overdue to update and tighten those down. So yeah, when we discussed this earlier in the year, we kind of had the action to wait until the AC cycle came through and then update based on that. But I wanted to, rather than having a manual step, I wanted to make it automated so there's not any or less chance of accidents coming. So yeah, if anyone's got some cycles, particularly, I guess if I don't know if the version that was produced in for the election is still around. I couldn't find it on Slack. But yeah, I've made some updates. There's a few different commits where I've explained the changes I made along the way. So it'd be good to get that in, and then afterwards I can start working on the or make a PR for the script that pulls down committers, the list of our committers, and checks them against the generated list. So it's kind of just an update and a PR review request there. Any questions, comments on that? Okay. So I guess Ruching, you go ahead for the next one. I'll find the link to the PR and add it as well.
Yep, thank you. A while ago, I suggested we introduce Tableau to look after the TOML files we had in our repository. The previous we had this. We are writing these TOML files at will, and they are laid. They are managed in a beta no offense, but it looks like it's a bit of chaos, and in these TOML files, some of the dependencies, the crates, they should be grouped and managed manually, and how to put it, say like crates from Rust VMware and that kind of thing. They should be put together. And so Tableau here is just a formatter to format these TOML files. It would make the TOML files we had in this repository looks more clearer, and we are already using this in Cloud Hypervisor repository, and it turns out to work well. So I'm proposing to introduce this. It's something like the shell check. It only needs to be run. It only needs to be run once in the creature in the repository root, and it can make sure our TOML files are in a good shape, in a good style. So I'm looking for more suggestions to how to actually implement and introduce this TOML files checking mechanism. That's basically it. Not
Yeah, I guess if we want. Sorry, Richard, I was going to summarize what the rules that you've there is customizable. The rules we've got is about reordering alphabetically, aligning entries, as you can see here, and within different sections, the set of dependencies are sorted in alphabetical order. So yeah, so routine, your first approach was to create this new workflow TOML check. Aurelian asked about putting it into the static checks, but the static checks typically run on a single component, don't cover all the components, and as Rucheng said, we only need to run it in a single place. So I think when we've been talking about it, yeah, you made this proposal, which is that we could create a new global checks like folder or file which contains other workflows, and that could contain Taplio, shell check. We've got like the kernel config version check, again, is just a kind of one-off check, and then we could put that into buildchecks.yaml. So I guess that's the questions for the community are they happy with the default rules we've got, or the base rules we've got to start with, and is there any thoughts on the best way to integrate it into the workflows, and what the idea of this kind of having this global checks approach is? So yeah, as you can probably tell, Rucheng and I have had quite a lot of discussion about this in Slack threads and stuff. But yeah, we're interested in if anyone else got any opinions. Yeah, Aurelian unfortunately is made the suggestion, put it in static checks. I shared why I didn't think that was appropriate, but then he's not been able to re-review and discuss, and now has been away. So we thought we would see if anybody else has got ideas. Or people just want to wait for Aurelian to come back to review it. People still here? Me?
Yep. Thanks for the summarizing. That's the very gist of it. That's okay. It's not a big problem.
Okay.
we can still wait for more inputs on this.
Okay.
I sincerely don't
Okay.
think that someone is going to block this. But Aurelia should be back next week, regardless. So let's wait like 2 more days, send him a private message or a public message like, hey man, do you want to review this? If he doesn't want to review that, if he's just abstain from that, we go ahead and get other reviewers for that. Does it sound fair?
Yeah, I think that's fine. I think it's a bit maybe frustrating is too strong a word, but we just didn't get any replies from Aurelian before he went away. But I guess we'll see if we can get them now he's back.
Yep.
Ruching, you also added an extra, more controversial topic from the Rust toolchain. Do you want to discuss that?
No, I just realized the 1.83 version is meets the standard, which is already 6 months old.
Mhm.
And if we stay at this toolchain version, it would basically preventing us from updating some of our dependencies. Some of our dependencies in the newer version of them, it stops compile with the current version of Rust toolchain. Namely, Rust VMM won't compile then.
Yep. So this is complicated. One of our downstream products, I don't think we've got any representatives on the call left. We did have at the start. Was the reason that we kept it back. They requested that 1.80 was the maximum version that we could have, because it broke them. As you say, we are now at the point where 180 is, I guess, like 9 months plus old. I have a meeting with that team on Monday to discuss the Rust versioning and how we can have a more sustainable approach going forwards. I'm not even sure if 6 months is the right thing. I think with Rust, obviously 6 months is okay for Go because they have 2 stable versions at a time, and 6 months is the lifespan. But for Rust, basically only the latest version is their stable and patched version. So yeah, we might need to review that. But yeah, I will.
Steve,
Yeah, go ahead.
so sorry for like, does it make sense to have a downstream blockiness? I understand what we discussed. I understand that we should try to help downstream, but downstream should try to help us in the same way, right? If this is not a two-way relationship, this is not a relationship at all. So a downstream will end up doing things in this way. Once they have a major release, everything will be bumped. Then they will want the newer version, and then like we have to adapt to that. After I don't know 6 years of they maintaining whatever they have to maintain for 10 years or more, they will want an older version. What do? We stop development because of that, right? And so far we didn't have any clear indication of what this downstream wants. It's not clear at all. So in this case of, hey, we cannot even build Dragon Ball because Dragon Ball depends on Rust VMM. We just bump. I think like there is no reason to talk to the downstream. We just bump. Otherwise, we are shooting ourselves as a project in the foot, and then we are blocking a bunch of other companies who want to use this just because of one downstream not being able to figure out the mess they have on their process.
Yeah, I think that's fair enough. And what I'm trying to get the clarity for on Monday is is that exactly that you said we don't have a proposal and an approach from them. So I'm trying to understand, look, what are you asking from the community? And then we can discuss it because arbitrary freezing of versions until the next version of Rail comes out and then jumping to latest, as you said, isn't sustainable for us and doesn't work for us. So I'm trying to work out what they would like us to do and then bring it back within the bounds of something that's sensible and bring it back to the community just because it might be that 183 isn't the right thing for us to go to next. Maybe we say if the rest of the community is happy, we go to 185 so we can get the 2024 edition in and there'll probably be some breaking changes and stuff in there or some new changes which cause issues. So yeah, I agree the approach that staying on 180 is not going to work. And yeah, we'll try and get that feedback back to the community next week. Otherwise, if we don't have any buy-in there, then I agree that we should just bump with in compliance for the rest of the community. But yeah, my view is maybe even 6 months isn't the right approach. Maybe we just say, no, we're always going to try and stay within one or two at like N-2 version or something like that.
I would strongly suggest we keep on the latest versions. On the latest version, on the latest supported version. If it means like bumping every month, we bump every month. Those companies, they have people to take care of their downstream,
Yeah.
right? So if they don't want to bump, they can use another version backport patches, right? They are not bumping. So how are they doing with the other Rust projects?
Yeah.
It's impossible that Red Hat is only packaging Kata containers in Rust. Right. So this is something that we all have to understand, and they have to understand as well. If they are keeping downstream branches for the other things, they should keep a downstream branch for Kata containers as well. Right. But it's not the burden of the community to do like if there is at least something, as you mentioned, right? Something that was clearly that was clearly on what they want, that would be fine, but we don't have that.
Yep.
Yeah, I agree. I also requested information about that, what the real issue is several times, and nobody got back. So I don't if as Fabiano said, why do we need to slow down the progress on some hidden pipelines that they have? They are creating their. So we are essentially trying to solve their problems, right? Because we have the burden on not moving fast enough that we essentially need. And I inquired this on the confidential container side. I inquired this several times on the Kata side, and nobody got back with real proofs on or documentation what the real issue is, right? And as Fabiano said, if you're relying on 170, then you should use the Kata version that's tied to 170 and then just backport the patches. That's how it's done today. And maybe we should have a policy like Kubernetes has, N-2. That's the only compatibility that we can provide, and not a compatibility to N-10 or 20 versions of Kata. We need to find some common ground here. But being blocked on a Z release or a minor release of Rust is kind of baffling to me, that we cannot move forward from 180 to 183.
Yeah. Yeah, so 186 is the current only stable version. So obviously there's betas for 87 and nightlies. It looks like 87 will become stable in 1 week. But yeah, I definitely understand the concerns, and I think we didn't maybe we had more of a discussion of this in VPTG around the Go version and kind of got a consensus. We didn't necessarily have that for the Rust. We had some initial proposals, but yeah, it sounds like we need to revisit that. And yeah, I will try and find out and share some feedback to the Red Hat team, and then next week we can have a wider discussion. And I think post 3.17 might be a good time to bump regardless, and say, right, this is kind of your warning. 3.17 is the last release that will be on 180. As soon as that's going, we're going to bump, and it might be that we bump to 186 or maybe even 187.
Yeah, we could have a policy, let's say 3 releases, we are going to be stable, and then we are bumping.
Yeah.
Like N-2, like Kubernetes has, right? They have like N-2 compatibility, API compatibility, version compatibility. All the APIs are only N-2 compatible, right? This is where things are changing.
Yep.
So maybe we could have policy something like that as well, because other way we are constantly blocked on downstream. And I mean, we have all the pipelines, we have all the build scripts, we have all the to just use it right away. Yeah, I still don't. Yeah, it's not. Yeah, okay. I still don't have the haven't seen the argument somewhere written down on what downstream is doing and why they are why they are blocking bumping of Rust versions. And I know how OpenShift is built, being a former Red Hatter. You have the same problems there, right, with the Go versions, API compatibility, but there's a team backporting stuff, like Fabiano said. Then you need to stick to the version that uses this version, and then just backport stuff, and from there. And that's what we're doing at NVIDIA with the Kata release, right? We chosen a release, what we are using, and just stick to this pipeline with all the versions that are in there, and build from there and cherry pick features that we need or for moving forward. And then when the time is right, bump up to the new release with the new versions when we feel it's safe and we have all the features. So I'm still struggling to see why we need to adhere to the downstream release cycles and not the other way around.
Yep. And I guess the reason is probably that they don't have a stable branch in the same way. So,
well, then they need to update their process. It's not honestly speaking, blatantly, it's not our responsibility to adhere to all the downstream and how they're doing releases and how they're managing releases.
yep. Yeah, I think that's fair. I think what we need to do is have some input from multiple downstreams, and if there's multiple downstreams that all want to have this policy of we'll bump Rust version every other release or something like that, then great. If we've just got one outlier, then agree we have to say sorry, it's on you. So yeah, maybe I think that's probably the next action is to work out a proposal that would work for a reasonable cross cut of downstreams.
Yeah, just imagine Red Hat telling the Kubernetes community, hey, you cannot bump up the Go version because our downstream process is too slow. This would never happen.
Agreed. Yeah. Ironically, I I actually had the opposite discussion with Red Hat last week, and that they complained that we weren't on the latest version of Rust and said, "Why are you not updating?" And I went, "Because you told us that you couldn't support anything later than 1.80, which is why I've got a meeting on Monday to work out what they actually want." But
And the interesting part is like that happened after the VPTG where we had Red Hatters there and where we
Yes.
discussed this because of Red Hat mainly.
Cool. Anyway, I think we're at time now. Thanks for the conversations. I'll kick these topics forward to next week. But yeah, that was good to set, and I'll speak to you soon. A few of us
Take care, Steve.
on the same call.
Take care, everyone. Bye-bye.
Bye.
Take care, guys.
Bye.
Bye, guys. Thank you.